This video covers Vrap sections A and B. To begin, let's look at the objectives of the Vrap module. First, to understand the terms ratio, rate, proportion, variation and constant of proportionality. 2, to devise relationships involving direct, inverse, joint and combined variation. 3, to solve problems involving proportional relationships. And finally, to simplify and compare ratios and rates. To begin, let's look at ratios. Now, a ratio is a comparison of two quantities that have the same units. The key is that they have the same units. A ratio can be mathematically expressed in two ways. Quantity 1 is to quantity 2, or quantity 1 over quantity 2. Now, a ratio has no units. It's dimensionless, and that's why it needs to be in the same units. Pi is a ratio of the circumference of a circle to its diameter. Okay, and that's the symbol pi. You can hardly see there. Equivalent ratios are obtained by multiplying or dividing each of the numbers in the ratio by the same amount. This is a similar method for determining equivalent fractions. A ratio should always be written in simplest form. This will require that natural numbers be written for both parts of the ratio. What I mean by that, you do not mix decimals in a ratio, you make them whole numbers. Common factors should be used to cancel ratios, and the numbers in the ratio must remain in the same order. So let's look at some examples. Firstly, I have simplified the following ratios. 1.2 is to 0.75. Now the problem here is that we have decimals, so we need to make them whole numbers, and the 0.75 has the greatest number of decimal places, so we're going to have to move it 2 to the right, and we do that by multiplying by 100. Whatever we do to that side, we have to do to that side, so we're going to have to multiply the 1.2 by 100 as well. So we get 120 is to 75. We can then simplify this ratio by dividing both sides by 15. 120 divided by 15 is 8, and 75 divided by 15 is 5. Okay, next 2 3/4 is to 3 1/8. First step here is to make them improper fractions. So 2 times 4 is 8, 8 plus 3 is 11 over 4 is to 3 times 8 is 24, 24 plus 1 is 25 over 8. From there they need to have the same denominator so we can compare them. Now both 4 and 8 goes into 8, so we're going to make them both over 8. To convert this, 4 times 2 is 8, so 11 times 2 is 22. We can now get rid of the denominators because we're comparing 8s, so it's just 22 is to 25. Next, 20 minutes is to 2 hours. Again, you need to have the same units, so our first step would be to write them in minutes. So we have 20 is to 120, and that's because 2 hours equals 120 minutes. From there we need to simplify. Probably easiest just to cross off the 0 to start with, and then divide both sides by 2. So we get 1 is to 6. Next, complete the following equivalent ratios. We already have the first number in both. To get from that 3 over the 12, we're going to multiply by 4, so we need to do the same to that second number, multiply by 4. So 3 is to 4 is equivalent to 12 is to 4 times 4 is 16. Next, now I have the second numbers, but I don't have the first, and 40 over to 12 I can't really reduce that. So the best plan of attack here is to simplify the 100 is to 40 to its simplest form, and we can do that by dividing both sides by 20. So 100 divided by 20 is 5. 40 divided by 20 is 2. So we have 5 is to 2 is to question mark is to 12. Now you can say, well, 2 over that 12 I'm timesing by 6, so I need to do the same to that 5. I need to multiply by 6. So 100 is to 40 is the same as 5 times 6 is 30 is to 12. Now let's move on. It may be necessary to split a total amount into smaller components in a given ratio. Okay, a good example of this is when mixing cordial. We need to know how much cordial and how much water given a ratio. So how many litres do I need in total? The following procedure is used to divide such quantities into a specified ratio. 1. Find the total number of parts. 2. Write the ratio in terms of fractions with denominators of this total. 3. Find each fraction of the quantity. And 4. Check the parts add to the total quantity. So let's look at an example. Divide 30 in the ratio of 2:3. So my first step is total parts. And that's 2 plus 3, which is 5. So to write this as a fraction, we can have 2 over 5 is to 3 over 5. They're our fractions. So from there we want to divide that 30. So firstly, so step 1, step 2, step 3, 2 over 5 times by 30, and you can do that on your calculator if you want. You can do it by hand and you'll get 12. 3 over 5 times 30 and you'll get 18. So 30 in the ratio of 2:3 is 12:18. Okay. Let's look at a practical problem. A donation of 150,000 is to be shared amongst 3 charities in the ratio of 2:5:8. How much would each of the charities be given? Again, total parts is 2 plus 5 plus 8, which is 15. So our ratio therefore becomes 2 over 15, 5 over 15, 8 over 15. From there, charity 1 would be equal to 2 over 15 times by that 150,000, and you get $20,000. Charity 2 would be 5 over 15 times by the 150,000, which gives you 50,000. And my final charity, charity 3, would be 8 over 15 times by the 150,000, which is 80,000. And you can always check whether this is correct by adding 80,000, 50,000 and 20,000 and realising you're getting that 150,000. What now? Practice Vrap B1 and Vrap B2 in the textbook.